Okay, in this video, we're going to see how we can make use of Git Hooks. And as everybody says, a good project will have a good Git Hooks. The one I'm going to demonstrate here, it needs some few tools. One is PMD is installed, PMD code scanner is installed according to this particular page I have given link. And step-by-step instruction is here. And please follow and make sure that PMD is installed in your system and it is available in your path, right? So this is the way I've explained it. Now let's go back here. There are two types of Git hooks are there. One is local, other one is server. I'm going to explain in a few moments. Regarding pre-request, after the PMD is done, make sure that you have Python installed. Most of the systems nowadays, operating system, they come with Python. If not, for example, in your Mac, if you don't have it, please install Homebrew. And once it is done, you can brew install Python. And also make sure that you have installed this SFDX plugin. And one other one you need to be aware of it. All these hooks um, have to be at the executable mode. That means the change mode should be plus X to all these hooks. So let me explain how the Git hooks works. And whenever some event happens, like for example, you are going to commit something, before that commit is called pre-commit. So you can put you can wire this Git hook, which will be called. Git will make a call back to that and see whether it is passing or not. If it passes, you'll give a exit 0. The exit code will be 0. If not, non-zero. And like that, you have another stage. And after commit is done, so you can have another hook. But the designers of the hook and Git, they took the hooks in a different level. If you look at the code, the source code of Git, basically you can look at how it is implemented. If you are very curious, and also you're a C programmer, this is the way it is written. And when you install Git and init a project for Git, all these sample files, are already created in your repo, in your project folder. The Git where you have Git init is done. So let me explain in my project how they look. Here, for example, my project is tree project, and in the .it folder there is a hooks directory. You can tree it to see what are the things already available. Some are sample. Sample means Git will ignore as a hook. It will not call back to that. But if it finds command like a file like this and it is in executable state, it will call back during the commit, right? This is a commit message one. Other one is a pre-commit, and you can have any number of things. It's called a pre-push before pushing the code, rebase pre, and pre-receive, and all those. Depending on your project, you can accordingly wire them. In our case, we're going to wire a couple of them. I'm going to explain. Let's go back there. So we go back here. As I said, there are two uh, places it can be run. One is locally, other one is on the Git server. I'm going to focus in this video only local ones, right? There are advantages and disadvantages in only using local, because if it's not enforced by best practices, the developers can delete them in the folder I just showed you. So that means that hooks will not be in use. So make sure that that is taken care. I give and explain in this page what are the issues and what are the benefits of local hooks, and how to give a solution to avoid that. I have explained that, right? So in my case, for example, I assume that Python is installed. My goal is somebody commits a code. I want to have that commit message would have some format like work item hyphen 1 2 3 4 5 6. It has to be the first word in the commit message. How I can enforce this? First of all, I have to give a commit message before they are when they are committing it. Say when they say git commit, you can put this message as a comment. In this message will be put as a comment for them as a reminder. That means they need to have, see here, something like that, right? Your ticket reference or something like that. Whatever you put here will be here, right? So if you put like this, wi work item 1 2 3 4 5 6, and it will go through. If not, it will bail out there itself. So again, I want to reiterate, if you put this uh, prepare commit message, whenever you make a commit, it will give a help text, right? Yeah, this one you need to follow this format. So that's pretty simple. And once that is done, for example, we can do the commit message here. So this one is just a help text, but we want to enforce it. When they give a message for the commit, that commit message, we want that to be in a particular format. What you can do is I given some regular expressions for the work item wi hyphen 1 2 3 4 5 6. You can go up to 6. You can change it whatever number you want, and then thereafterwards I'm telling 30 characters can be there. So this way, what it does is the Python recompiles this regular expression and checks whether it is matching or not. If it matching, it'll give valid commit changes. We will proceed. It'll otherwise it'll limit with the error exit code 1. So what happens is when you put a exit 1, GitHub will GitHook will find out, yeah, this is not successful. It will bail out. So whenever you write this commit message code, either in Python or whatever, a lot of folks write in Ruby. Nowadays, most of the folks write in Python or a Bash. You make sure that when this one is not to the right format, you bail out with the exit code non-zero. Then Git Hooks knows that, yeah, that's not a way I can proceed. It'll bail out. The next one is I've shown how you can test it. If you look at it, how Git Hooks works is in this particular commit, Git will send to itself that commit message, what it keeps it in that folder, right? .git folder. It will find out that file. It will pass it to this command, what we have wire it as a commit message. This Python script will get this file. That's why I'm reading that file, input file. So as the first argument and the reading into a string, and I'm checking for the regular expression. So I am just showing the under the hood how it works. So if you run it yourself, what Python, Git hook is basically doing, I'm explaining here. So if this is my commit message script, Python script, which is the state is the mode is executable, and if I run that Python that one, and you pass that file as the first argument, it will find out bailout, right? Because whether it is right formatted or not, etc. Invalid commit. If it is a valid one, it will come back and say, yeah, this is good. So now we understood how this hooks works. Git will make a call back to this function during the commit. When it is collecting the commit message, it will check and make a file and send it this particular hook we have written, and we'll find out whether to go for further or bail out, right? So here I have given a demo. You can easily see what I've done is I have wired PMD check if in case of Salesforce development. When they give a commit, git commit, I'm running couple of things. One is a PMD, checking the PMD violation 1 and 2, P1, P2 is not there. If it is there, it will bail out there itself. So that means the priority is less than 3. If it is there, the count is there, and you will get number of errors is equal to how much is the count. Then it will continue, and you can even wire a deployment, check only deployment here itself, so that way it finishes, right? The goal of this is this: well, as soon as the developer commits, it will check for the PMD errors. If not there, it will go to deploy itself. So here it is shown, and I made one class, and it got deployed, right? So, and if we can also look at the Git log, it says that it is was successful. I created that commit. If the commit message was not right, it will bail out here itself, right? Your message may be correct, but if PMD has got violations like P1 and P2, then it will fail bail out. And if the deployment also has got an issue, then it will bail out. So you can't commit a code with the violations, or code cannot be deployed. Non-deployable code will not get committed. It may be too strict for your environment, but I generally recommend you can put PMD, which is very fast. This may take time checking deployment. May take few minutes. So um, in general, start with this one. Number one is the commit message should be of a particular format, and PMD violation should be below. You should not have P1 and P2. P3 is okay, right? We can fix it later. Those two are important. This one is optional. And I've explained one step by step where I'm using the pre-commit here. That means I'm running the deploy. Um, so you can see that if you want want to test this pre-commit, I've explained here how you can test it yourself. Script used for this one, right? So now what I'm doing is I've added a new document 9.md. I'm adding it, staging it, and I'm committing it. When I give a git commit, it'll ask me what is the commit message. Then it will go for a PMD test, as well as it will deploy. So what I've done is step by step I explained, adding a PMD code scan in pre-commit, and this is a complete pre-commit after all the steps are put in. You can see that I put the PMD rule set, threshold for the PMD, and where the code is there for PMD to scan. And this is pretty much you're running PMD in a bash mode. And here it checks for the violations. If no violation, it goes further. And if there is an error, it will say stopping the deployment. Once that is done, we will go through quick deploy. This is an optional step. It may take some time. So my recommendation is that do up to here and see how everything is successful with the developers. Thereafterwards, you can introduce this one. Here I given a demo of it. So what I am doing is I'm committing it, and now there is no error in PMD. I am going for the quick deploy, and everything is completed. So here I've explained, put a GIF file which shows what I'm basically doing it. So I'm adding something, 5.md, then see now it is running PMD. PMD is pretty fast. It will come back in a few moments. Thereafterwards, it will go to check for the quick deploy. So that's all the fundamentals of Git Hooks. What I explained is only as local. That means we have used the local side, the developer side hooks. There are also some server side hooks. Say I'm just here, and if you can look at, I'm giving invalid commit just to make it to fail. This will be bailed out. Okay, and Git will reject because it's not in the right format. You will say in my invalid commit message bailing out. But you give a right one, it will go through. In my case, I went through even quick deployment, etc. But the commit message was not right, so it bailed. So they have to, this way you can enforce. You can't say enforce. You can bring some discipline to commit messages, as well as if you are implementing quick deploy check, I would say check only deployment, and this is the option, right now. Here I'm putting the right in a commit message, it will go through. um, okay, I'm committing it, everything is good. If you can after you can see that as I was explaining, Git basically callbacks your function with that commit message. Um, and other part is you have a server side, which is the best way to do, but it requires a lot of support from Git administrators, and but it supports pre-receive, update, and post-receive. But I think without much work on server side, if you implement prepare commit message, pre-commit, and commit message, which I've explained. Again, I want to give a summary. Pre-commit messages, um, before they commit, give them a clue that what is the commit message you are looking for. Give them a format, something like, like this one. You must include ticket reference and the format, etc. And you can clearly say if it is not in this format, it will be rejected. Then pre-commit, that's what I did a couple of wiring here. So you can look at that. That will be called before commit. So let me, sorry for the scrolling. And this is a command, uh, pre-commit the file. It's a bash file. Yeah, that's why I put here. And it runs PMD. It looks for the violations. Then it runs a quick, check only deploy. So that's a pre-commit. Other one is a commit message, right? So commit message, as I explained, it's a regular expression based. It checks whether the message it got, commit message, is following a particular pattern. And now feel free to use the script, change it as needed in your project, and it'll give you, with the matches, it's a valid, otherwise invalid, it will bail out there itself. Hope I've explained it, but if you are a C programmer, like to commit to Git development, it is open source. It was created originally by Linus, and any one of us can help them maintain them. So if you are curious, this is a file, and here Git developers keep the samples here. Sample means it will not be executed, like I said. If you remove the dot sample and make it executable in your way, it will be executed. And the reference I also given how to install PMD um, in this book, and in the video where it will be hosted, I will give a link to this as well. Um, Pretty much I have, um, I think I covered what are the goals. The goals of the Git Hooks is make sure that the commits are having high quality, and the code what they have developers have developed is deployable, and it's a one way of enforcing good code quality. Thanks for listening to this video, and see you in next video. Thanks. Bye.